Hi, in this video we are going to discuss about decision boundaries. The standard way that we've been thinking about learning algorithms until now is in the query model. Based on training data, we learn something, and then using that learned model, when we're given a query example or a test point, we guess its label. An alternative and perhaps a less passive way to think about a learned model is to ask what sort of examples will it classify as positive and what sort of examples will it classify as negative. In this figure, the background of the image is blue in region that would be classified as positive and colored red on region that would classify as negative. The green solid line that separates the positive and negative regions is what we call the decision boundary. Decision boundaries help us to visualize the complexity of a learned model. For a KNN classifier, the decision boundaries can be varied by adjusting the K value. This image depicts a KNN classifier with a low K value. A KNN with a low value of K, say for example 1, will show jagged decision boundaries. Since the classifier only considers one nearest neighbor, it is not able to generalize the overall distribution. That is why it is prone to overfitting. On the other hand, when the K value is too large, the decision boundary becomes a lot simpler. However, since there's a huge bias, the classifier is not able to detect the variance of the data points. To put it simply, the classifier does not mind about the smaller details. This is the reason why a KNN classifier with too large K value is potentially underfit. So as you can see, as the K value increases for the KNN, the simpler its decision boundary becomes. Now that we already know about decision boundaries, let's look at how decision boundaries look like for a binary tree model. If we can recall, the features in our binary tree model ask questions that are answerable by yes or no. For real values, on the other hand, for us to use the same concept of answering a yes or no question, we are going to make use of feature value thresholds. That is, we ask whether the feature value exceeds a certain limit or not. Let's use the ski versus snowboard problem we have discussed in the video about feature scale in KNN. This time we are going to try doing it using the binary tree model. As you can see here, using thresholds, we can now have binary feature values. So if we are going to plot this, we can see that thresholds in the nodes will have corresponding slices over the x or y axis. Breaking this down, the first threshold is if the height is greater than 160, it is supposed to be a ski. However, if not, we consider another threshold, and this time, if the width is greater than 20, then it is supposed to be a snowboard. Traversing through the tree, we'll get the following decision boundary, which is the green line. The region in the lower right is where a point would classify as a snowboard. The region on the upper left, however, is where a point would classify as a ski. So for this binary tree, since it is a shallow tree, we can evidently see that the decision boundary is relatively simple. Using this visualization, we can therefore say that this model is potentially underfit. However, if we increase the depth of the tree, we can see that the decision boundary becomes even more complex and jagged. So therefore, we can say that this model is prone to overfitting. So that's it. The main takeaway from this video is that decision boundaries can help us visualize the complexity of our learned model. With the use of decision boundaries, we'll be able to tune our hyperparameters more effectively by being able to see the balance between overfitting and underfitting. In this video, we were also able to see the effects of adjusting the hyperparameters to the decision boundaries of a KNN and a decision tree. More particularly, we are able to see for a KNN classifier how the decision boundary changes when we adjust the K value, and on the decision tree, we have also seen how the decision boundary changes when we adjust the depth. So that's it for this video, and thank you for listening. See you next time.